Okay, so in this video I'm going to be going over the day 2 warm-up questions. Now before I go over these questions, I do want you to access this warm-up document, and I want you to try to answer these 4 questions on your own. Okay, so pause the video now and try to work through these questions on your own, and then I will go over each of the questions one at a time so you can check your answers. The purpose of the warm-up is just to kind of refresh your memory from the problems we were doing from the past day before we get into your quiz for today. Okay, so the first question says, a car traveling at a constant velocity of 15 meters per second travels a distance of 40 meters. Calculate how long it takes for the car to travel this far. Okay, so see if you can answer this question on your own. Okay, so as I'm reading this question, the first thing I'm looking at is it says the car is traveling at a constant velocity. Now, the only equation there is for constant velocity is the d equals v times t equation. And you might say, but wait, that's not the equation that's up there. Well, this equation I just wrote and this equation, v equals d over t, are the same equation. It's just this one is solved for v and this one is solved for d. Okay, so really it's the same equation, just a different way of writing it. So this is my one and only constant velocity equation. If you look 15 meters per second, from what we talked about yesterday, you should know that meters per second is the unit for velocity. So to base off of the unit, I know that this is velocity, and it travels 40 meters. And so I'm going to label this d for distance or displacement. A question about how long, which is our unknown, is always going to be a question about time. So we want to know how long it takes for the car to travel this far. So I take my constant velocity equation, and then I'm going to plug in my givens. So d equals v times t. In place of d, I'm going to put 40 equals v. I also have as a given, that's 15. And then t I'm going to leave in there because t is my unknown, and t is what I'm solving for. So it's just going to be 15 times t. And if I want to get t by itself, I say what's being done to t is being multiplied by 15. So to undo that multiplication, I need to do the opposite of multiply, which is divide. And so I'm going to divide both sides by 15, because 15 is what is multiplying t. So I divide both sides by 15, and 40 divided by 15 is 2.7 seconds. Okay, so the unit for time, remember, is seconds. So that is question number 1 on this form. So hopefully that's the question you got, hopefully that's the answer that you got for this question. Okay, 2.7 seconds. So pause it there if you need to look over that, and then we're going to move on to the next question. Okay, question 2. This is a family taking a road trip together completes their trip in multiple segments. They travel a 60 kilometers for 2 hours, then 120 kilometers for 3 hours, and finally 30 kilometers for 0.5 hours. Calculate the average speed of the family car during this time. So the second thing we talked about yesterday, after we talked about constant velocity, was solving problems with average speed. And average speed, again, you use in situations where you don't have constant velocity the entire time, okay, when you have segments like this. So the equation for average speed is equal to the total distance divided by the total time. And so to get the average speed here, to find d total, I'm going to find all of my distances, and I'm going to look at the units to figure out which ones are the distances. 60 kilometers, 120 kilometers, and 30 kilometers. Those are my 3 distances. So for d total, I'm going to do 60 plus 120 plus 30. Okay, so that would be my total distance. And then on the bottom for t total, I'm going to add up my times. So I have 2 hours, I have 3 hours, and again, I'm just looking at the units to know that this is time. And then I have 0.5 hours. Okay, so t total would be 2 plus 3 plus 0.5. Now, if you look at what I'm dividing, I have this is kilometers on the top and this is hours on the bottom. And so my final answer is going to be in kilometers per hour. So I'm going to do 60 plus 120 plus 30. That gives me 210. And then on the bottom, 2 plus 3 plus 0.5 is 5.5. And if you divide, you should get the correct answer. I'm going to round to one decimal place, 38.2, and that's kilometers per hour. Okay, so that is the average speed of this family taking a road trip together. Okay, so hopefully that's what you got for question number 2. Pause it there if you need to check your answer again. Okay, question 3. Okay, so question 3 and question 4 are both problems involving constant acceleration. Okay, so see if you can get the answer for question 3. Okay, so question 3 says a soccer ball rolling away from a player at 2 meters per second. As you're going through, look for context clues like stopping or at rest, and also look for numbers, and pay attention to the units. Remember, meters per second is the unit for velocity, so when I say 2 meters per second, I know that's got to be a velocity. Now, keep in mind, when you have acceleration, you always have an initial velocity and a final velocity, so I need to continue reading to figure out which velocity this is. So the soccer ball rolling away from a player at 2 meters per second is kicked, so it accelerates at a rate of 0.25 meters per second squared. Look at the units, meters per second squared. What has units of meters per second squared? This has to be acceleration, because nothing else has units of meters per second squared like we talked about. If the ball travels 42 meters, what has units of meters? It's got to be displacement. So I'm going to label that dx for displacement. Now the question says calculate the final velocity of the ball. Okay, so my unknown is going to be v final. That means this other velocity that I labeled has to be v initial. Remember, you have to do this first part first. Okay, you have to have 3 givens and 1 unknown. Because there's 3 different equations, and the way you know which equation to use is there's only one equation that has these exact 4 variables. In other words, there's only one equation that has vi, has a, has dx, and has vf. Okay, the equation you should be using is the equation that looks like this. vf squared equals vi squared plus 2a dx. Okay. And again, I know to use that equation because this is the only equation that has all 4 of those variables that I had previously identified. Okay, so if I want to get v final by itself, I'm going to start by plugging in what I know. I don't know vf, so I'm going to leave that in. vf squared equals vi squared. I do know vi is 2. Okay, so that's going to be 2 squared. By the way, when you're plugging into the equation, make sure that you don't plug in the units. Just because otherwise it gets more complicated than it needs to be. Okay, so this is 2 squared plus 2. A is 0.25, and then dx is 42. Okay, and then I'm going to continue the work. I guess I'll use the space down here. Okay, so vf squared, I'm just going to simplify this. 2 squared is 4, plus, I multiply this, 2 times 0.25 times 42. Okay, so that is going to be 21. Which means vf squared is going to be equal to 4 plus 21, which is 25. And I don't want vf squared, I want vf. And so I need to undo the square right here. And the opposite square is square root. Okay, so I'm going to square root both sides, and you should get vf equals the square root of 25 is 5 meters per second. Okay, and so this is going to be the answer for question 3, and hopefully that's the answer that you got. Okay, pause it here if you need to check any of that work. Okay, we're going to do one more question. Okay, question 4 is another question with constant acceleration. It says a flying saucer traveling at 120 meters per second. Again, based off the units, meters per second, I know that's a velocity. I'm going to keep reading to see if I can figure out which velocity that is, the initial or the final. It says it accelerates at a rate of 5 meters per second squared. Okay, so this is going to be the acceleration until it reaches 140 meters per second. Now, as I'm looking at this, I realize I made a little mistake. Okay, and I know I made a mistake because this is the acceleration that I just underlined. I can't have two accelerations. Okay, I can only have one. This should actually be 140 meters per second, not meters per second squared. In other words, this number right here should be a velocity. Now, you have to think to yourself, is the 140, is that happening at the beginning or the end of the problem? Now, based off the context, it looks like the flying saucer was traveling at 120 meters per second at the beginning, so that's going to be VI, my initial velocity, and then 140 meters per second, that would be V final because that's happening at the end of the problem. Then the question says calculate how long this acceleration takes. Remember, a question about how long is always going to be asking for time. So I want the equation that has VI, A, VF, and T. Okay, so see if you can answer this question on your own. I choose the equation that has those four variables. And then I'm just going to plug into my equation. I'm going to plug in for VF, that's 140. I'm going to plug in for VI, V initial, that's 120. Plus A times T. The acceleration is 5 meters per second squared, so 5 times T. Okay, now make sure that you're using your algebra skills that you've developed over the years. You cannot combine like terms here. This is not 125T. This 120 cannot be added to this 5. Okay? You can't add apples and oranges together, right? These are not like terms. Okay, so 120 is just a number. This 5 is attached to the t, so this you cannot combine the 120 and the 5. Okay, so if I want to get t by itself, I ask myself, what is being done to t? Remember that we basically have to do everything that's being done to t if we want to get t by itself, and the way we do that is with reverse PEMDAS. So the things that are happening to t is, number 1, it's being multiplied by 5, and number 2, it's being added by 120. Okay, so if I'm going to do PEMDAS backwards, the first thing I want to try to do is I want to subtract if I can. Okay, and so I'm going to start by subtracting 120. Okay, to get rid of this 120, and I have to do it equally to both sides. Okay, so I'm going to simplify. I'm going to write it up here. 140 minus 120 is 20. This canceled right here, and that leaves behind on the right side 5t. What's being done to t now? It's just being multiplied by 5, and so I need to do the opposite of multiply, which is divide. So I'm going to divide both sides by 5 to get t by itself. Okay, and so t is going to equal 20 divided by 5, which is 4 seconds. Okay, and so that is the answer for question number 4. So hopefully that's what you got for question number 4. And hopefully that gives you a little bit more practice before you work on your quiz for this constant acceleration part of the unit. As always, please let me know if you have any questions. And I'll see you in the next video.